Here's a system of linear equations which I'm going to solve by putting the equation into an augmented matrix and doing the row reduction, getting it down to reduced row echelon form. So I'm going to put this into a matrix. And I'm going to go about my business doing the row reduction, and I'm going to do this just the way I would do it. I haven't worked this ahead of time, so it may not be, I may not take the most efficient route here, because I'm just going to do whatever row operations I see fit as I go along. So I have 3 options for row operations. I can always swap rows, I can always multiply a row through by a non-zero constant, and I can add a multiple of one row to another. And my goal essentially is to get ones here, here, and here, zeros here, 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 and here. Depending on the system and whether it has a unique solution or infinitely many solutions or no solutions, that may or may not be possible. So we're sort of leaping out onto an adventure here, but you keep that general goal in mind to get the ones along the diagonals and zeros everywhere else and get as close to that as you can, essentially. So I am going to, in this first step, add -2 times the first row to the second row. So I'm going to manipulate the second row here using the first row. So the first row does not change. It's only in my head that I'm really changing it, and just for a second. So I'm going to do this plus a -2 times that is 0. This plus a -2 times that is -3. This plus a -2 times that is -1. This plus a -2 times that is -12 3 is -9. And then similarly, I'm going to now get a 0 here. Unfortunately, I'm going to annihilate my 0 here temporarily, so I'm kind of going a little bit backwards here, but a lot of times that has to happen. So I'm going to use row 1 to get a 0 in that first spot in row 3. So row 1 is not going to change, row 2 is not going to change. I'm going to do this plus a -3 times that, this plus a -3 times that, this plus a -3 times that, this plus a -3 times that. And so there I have it. And so I have my 1 here now, I've got zeros here and here. And generally speaking, the order I go in is try to get a 0 here, here, then here, 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 then here. That's sort of a good rule of thumb. Again, depending on the system and depending on how things work out, you may do things in a slightly different order and you may backtrack a little bit. It's okay. If you just keep pounding away at it, you'll eventually get it down to where you need it. So my next goal would be to get a 0 here, which is easy because I happen to have a -3 right here. Generally speaking, it's nice if the row you're working with has got a 1 in the place that in the column that you want to annihilate things in. But if they match like this, then you're all good. So I'm going to subtract, or add if you like, -1 times row 2 to row 3. Same as subtracting row 2 from row 3. Let me try to, okay. Actually, I'm gonna change my mind here. I'm gonna multiply row 2 through by -1. So that's legal because you can always multiply through a row by any non-zero constant that you want. Now I don't have to do subtraction. Now I can just add. And I know that from my own experience, when I do subtraction instead of addition, I tend to screw up. So I just avoid it when I can. And you have a lot of flexibility here to do things that suit your own mathematical proclivities, especially when you find out things that tend to lead you to make mistakes, and you can try to avoid them. So now I'm just going to do add row 2 to row 3. So there's going to be a 0 here, a 0 here, a -3, and a -9. And then I'm going to multiply row 3 through by -1/3. And then I'm going to use, now I said the goal was to get 1s along this diagonal, and I can always get a 1 here if I want to. I could multiply row 2 through by a 1/3, but then I'm going to introduce fractions. Another thing I like to avoid when I can, which is not always avoidable, but here I don't have to do that multiplication of row 2 through by a 1/3 yet, because I can just wait. I'm going to use this 1 to get the 1 in the third column in the third row to get rid of the ones in the third column in the first and second rows. So I am now going to, which I haven't done yet, I'm now going to combine two moves. I'm going to get rid of this one and this one. Actually, let me not do that. I'm just going to get rid of this one here. I'm going to do row 1 plus a -1 times row 3. So then this row 3 is nice to work with because you have zeros here and here. So if you do this minus this, you get 1. This minus this, you get 1. This minus this, you get 0. This minus this, you get 3. And you can maybe see, maybe not. This looks a little bit weird if you've not done it before. So you can maybe see that I could just as easily, instead of doing this minus this and getting this row and then writing this row down again, and then I'm going to do this minus this, I could do both of those steps in the same jump. I'm going to keep them separate just because a lot of people watching this will be brand new. So I'm going to do this minus this, 0, this minus this, 3, 1 minus 1, 0, 9 minus 3, 6. And that is nice because I can now multiply row 2 through by 1/3 and I don't introduce any fractions. And then I just have one thing left I have to do. I get a 0 here by doing the first row minus the second row. So I'm going to do 1 minus 0 is 1, 1 minus 1 is 0, 0 minus 0 is 0, 3 minus 2 is 1. And then the other, the other two rows stay the same. And if I translate that back to a system of linear equations, I get x equals 1, y equals 2, z equals 3. And then you plug that in and check. Of course, you want to plug in 1 plus 2 plus 3 is 6, 2 minus 2 is 0 plus 3 is 3, 3 times 1 is 3, minus 3 is 0, so that is checked and it works, and that's my solution. Now if you go back and you look at this work, like I said, this is not the most efficient route because there were certainly times when I could have combined two moves. Like I could have done this, this move and this move all in one. And I think there was another spot where I took 2 steps to do something. I can't remember what it was. Oh, like this step was unnecessary. Here I could have gotten to here and multiplied that through by a negative all in one step. So there are places where you can be more efficient. But the goal when you're just starting out is to just get so that you're competent, and then the efficiency will come later. Once you see what you're trying to do and you get the idea of these row operations down, then you can start to get fancy. Okay, very good.